Hello everyone. I'd like to take a look at another property of parallelograms. The property that I would like to prove is that the diagonals of a parallelogram bisect each other. So here our given information again is just starting with a parallelogram. That means that we can start with just the definition of a parallelogram. And we want to show that the diagonals bisect each other. So let's draw in our two diagonals. So we have the diagonal QS, and then we have the one from P to R. So we want to show that these bisect each other, which means that this point here, that intersection, has to be right smack dab in the middle of PR, and it's also in the middle of QS. Let's give it a name so we can refer to it. We'll call it M, since it does end up being the midpoint. But what we want to show is we want to show that PM is congruent to RM. Right, so that is getting cut in half. And we also want to show that QM is congruent to SM. So that diagonal is getting cut in half. So what we want to prove, if we write that down, we want to show that PM is congruent to RM, and we also want to show QM is congruent to SM. Okay, so let's start our proof. Again, our given information here is just that we have a parallelogram. So PQRS is a parallelogram. So if we're given that information, we can use the definition of a parallelogram, and from that we also have two properties that we already discussed. So we also know that the opposite sides are congruent and the opposite angles are congruent. So if we have a parallelogram, the definition tells us that the two pairs of opposite sides are parallel to each other. So by the definition of a parallelogram, so this is just directly following from what our starting information was. So by the definition, we get the two pairs of parallel sides. So we know that QP is parallel to RS, and then our other pair, we have QR is parallel to PS. Okay. And just like we've seen many times before, whenever we're given parallel lines like this, we know that's going to give us some angle relationships. In this case, our two diagonals, those are going to act as our transversals. And what I'm going to end up doing here is basically I'm going to focus on two of the triangles that I ended up with by drawing in these diagonals. The diagonals divide this up into four separate triangles, and we kind of have two pairs. So I got triangle QMP here, and I have triangle SMR. So those two kind of go together. So those are the ones I'm going to focus on. So within these two triangles, let's take a look at the angle relationships that we have. We have vertical angles in the middle, and then using our parallel lines, we can get some alternate interior angles. So I know that these two angles are congruent. So let's see, we have angle PQM is congruent to angle RSM, and that was using QS as the transversal. If I use the other transversal, still using these two parallel sides, we get these two angles are congruent. So, and we also know that angle QPM is congruent to angle SRM. And our reasoning there, that's the alternate interior angle theorem. Okay, so that gives us two pairs of angles, and as I said, we could use the vertical angles in the middle. That's a pretty nice piece of information to know as well. But with those two angles, we do need at least one pair of sides. Remember these markings in here, that's what I want to end up showing. But we do know a property already. We know that the opposite sides of a parallelogram are congruent. So I do know that QP is congruent to RS. So let's say also QP is congruent to RS. And that was one of the properties of a parallelogram we have already discussed. So the name of that theorem was just the parallelogram opposite sides theorem. Okay. So now, just looking at those two triangles, we have two angles and we have the side in between them for each triangle. So now I can say that these two triangles are congruent. So therefore, triangle QPM is congruent to triangle SRM. And that is angle side angle based on the way that information is laid out. The angle side congruence theorem. And now that I know that these two triangles are congruent, I know that the corresponding parts are also congruent. So, because the triangles are congruent, PM matches up with RM. Those are corresponding parts, so they have to be congruent. And the same thing goes for QM and SM. So then PM is congruent to RM and QM is congruent to SM by corresponding parts, and I will abbreviate that. Corresponding parts of congruent triangles are congruent. So we know that PR and QS were our diagonals, and because these segments ended up being congruent to each other, we know that M is the middle. It's the midpoint of both of those segments. So then we can finish up here and say, and the diagonals bisect each other. Which is what we're looking for to start with. And that's it. So once again, using congruent triangles, show that the triangles are congruent, and then use the corresponding parts. We can prove another property of parallelograms. So that gives us a total of 4 different properties, which I'm going to summarize just really quick. So we were able to prove these first two in another video, and then this last one we just proved, and this last one, got a little mistake here, so the consecutive angles are supplementary. That one just comes from the fact that these sides are parallel. So our 4 properties of parallelograms, these follow from the definition, so these aren't included in the definition. The definition is just that the sides are parallel. These are all separate properties that we can prove. So the opposite sides are congruent. So based on my picture here, we know that AB is congruent to CD, and BC is congruent to AD. We also know that the opposite angles are congruent. So angle A is congruent to angle C. Angle B is congruent to angle D. Our third property is that the consecutive angles are supplementary. Consecutive angles means 2 angles that are right in a row. So for example, the measure of angle A plus the measure of angle B, those 2 angles have to add up to 180. So the angle here and the angle there. And then we have a bunch more. So then making my way around, measure of angle B plus the measure of angle C is 180. Measure of angle C, measure of angle D is 180. And the last one, the measure of angle D plus the measure of angle A. Those have to be 180. So it's just two angles that are right in a row. They have to add up to 180. And then the last one that we just showed, the diagonals are, they bisect each other. So the point here, the intersection, that ends up being the midpoint of both of those. So we know that AM is congruent to CM, and we also know that BM is congruent to DM. So there are the four properties of parallelograms.